Hello children, our today's topic is types of sets. So the first type is empty set. Okay, the first one is empty set. As the name suggests, a set which does not contain any element is called empty set. Okay, a set which does not contain any element is called empty set. This empty set is also known as void set or null set, and there is a symbol to represent this empty set, null set or void set, and the symbol is this phi. We read it as phi. Okay, the symbol is phi, and in roster method this phi is denoted by this bracket, curly bracket. Okay, since it's empty set, so we will not write anything in the within the bracket. Okay, so it's empty set. Now let us see some examples of empty set. If x belongs to set of natural number, means this x belongs to set of natural, here x is a natural number such that x lies between 5 and 6. So here x is a natural number and one condition is given that this x lies between 5 and 6, and we know that there is no natural number between 5 and 6. It means this set is a null set or phi or empty set or void set. So this is equals to phi. Okay, now next example. If B is a set of x, set of all x, such that x square minus 2 equals to 0 and x is rational number. You can make so many examples. Okay, then here what is this x? X is a rational number and x is such that x square minus 2 equals to 0. So when you simplify, you will find that x square equals to 2 and x is equals to root 2. So here the value of x is plus minus root 2. One is plus root 2, another one is minus root 2. Okay, and this root 2 is not a rational number, so there is no rational number here. Okay, so this set is also an empty set or null set. So you can write so many examples. Okay, now the next type of set is singleton set. Okay, singleton set. So the definition is a set containing a single element. Okay, a set consisting of a single element is called a singleton set. A set consisting of a single element is called a singleton set. For example, if I write, so it's a singleton set because here we have only one element in this set, so it's a singleton set. Another example, x for all x such that this x belongs to set of natural number and this x square is equals to 9. Okay, so x square is equals to 9. It means x is equals to plus minus 3, but we cannot include minus 3 because here x belongs to n. So here this is a singleton set, and this is equals to the singleton set 3. Okay, so this is set builder form and this is roster form. So in set builder form, this is the way to write this singleton set in set builder form, and this is tabular form. But when you observe, you will find that here we have only one variable, one element, so that is why it is an example of singleton set. Now the next type is finite and infinite set. So a set which is empty or void set, okay, or null set, contains no element. So a set which is empty or contains a definite number of elements is called a finite set. Otherwise the set is infinite. For example, set of days of the week, we can write this set, okay, there are definite number of elements in this set, so this set is a finite set. Whereas this set of natural numbers, there are infinite numbers, that is why the set is called infinite set. Okay, now when two sets are said to be equal, when two sets are said to be equal, so the two sets have, if the two sets have exactly the same element, if the two sets have exactly the same elements, then they are called equal. Okay, and we write it as, if suppose we have two sets A and B and they are equal, so mathematically we'll write set A equals to set B. Otherwise the sets are said to be unequal and we write A is not equals to B. Okay, so two sets A and B are said to be equal if they have exactly the same elements. Okay, for example, set A is given 1, 2, 3, 4 and set B is given 3, 1, 4, 2. See the order, see the elements. They have same elements, the only difference is the order. So in set we know that order doesn't matter. So here this set A is equals to set B. Okay, they are equal because they have exactly the same elements. Okay, now we will solve question based on these definitions: finite set, infinite set, equal sets. Okay, so now we will solve exercise 1.2. Now see the questions from the exercise 1.2. Question number 1 is, which of the following are examples of null set? We have to identify the null set. So null set means empty set, void set, and mathematically we represent it by using this symbol phi. Okay, or in roster form this curly bracket. Okay, so which of the following are examples of null sets? So the first question given is set of odd natural numbers divisible by 2. Okay, this we have to check whether this set is a null set or not. So set of odd natural number divisible by 2. So first we'll find all the numbers, natural numbers divisible by 2. So 2, 4, 6, 8 and so on. So when you observe, you will find that each number is even. Okay, we don't have any odd natural number divisible by 2. So this set is a null set. So we will write this set is a null set. Okay, second, set of even prime numbers. Set of even prime numbers. So first we will see all the prime numbers. So here we have 2, then 3, then 5, then 7, then 11 and so on. But we have to write a set of even prime numbers. So out of this number we have only one number 2 which is even as well as prime. So this set is set of 2 which is not a null set. Here we have one element 2, so it is not a null set. Now the next set is set of all x such that x is a natural number and x is less than 5 and x is greater than 7. So you observe here, when you observe here, you will find that here x is less than 5 and x is greater than 7. Okay, so a number cannot be both means at the same time cannot be less than 5 and greater than 7. Okay, here this we are talking about the same number x. So x is less than 5. If a number is less than 5, it cannot be greater than 7. Okay, or if a number is greater than 7, then it cannot be less than 5. So this is again a finite set, sorry, a null set. Now next is set of y such that y is a point common to any two parallel lines. We know the definition of parallel lines. Parallel lines never intersect each other, so there is no common point. So this set is also a null set because there is no common point. Okay, because both the lines are parallel. Now the second question is, which of the following sets are finite or infinite? We are given 5 sets and we have to identify whether the set is finite or infinite. So let us see the first one. The first set given is the set of months of a year. Okay, so of course it's a finite set because it contains 12 elements. Set of months of a year, in a year there are 12 months, so it contains a definite number of elements and there are 12 elements, so it's a finite set. Okay, now this set is infinite because it has infinite number of natural numbers. Okay, so this set is infinite. Okay, from the dots it is clear that the set is infinite set. But here we can count. Okay, there are definite number of sets we can easily count. So this set is a finite set. Okay, and the next one, the set of positive integers greater than 100. So greater than 100 positive integers, so there are infinitely many positive integers greater than 100. Okay, there is no limit, they have not given any limit. Greater than 100, so greater than 100 there are infinite numbers, so this set is infinite set. Okay, and the last one, the set of prime number less than 99. So the set of prime number less than 99 is a finite set, as the prime numbers which are less than 99 are finite. We can easily, there are definite numbers. Okay, we can say easily count. So this set is a finite set. Okay, now question number 3 of this exercise 1.2 is also same. In the next, means in this question also we have to state whether the set given is a finite set or infinite set. So this question number 3 is for homework. You can do it on your own. Okay, now we'll move to the next question, question number 4, and the question is, in the following means the questions are given and we have to state whether this A is equals to B or not. Means we have to check whether two sets are equal or not. So let us see the first part of this question. So here set A is given A, B, C, D, and set B is given D, C, B, A. Before you solve this question, you should know the definition, means, or the condition when two sets are said to be equal. Okay, so just now we have seen that the two sets are said to be equal if they have equal or exactly same element. Okay, order doesn't matter, but the element should be equal. Okay, both have same or exactly same element. So when you observe this set A and set B, you will find that they have exactly same element. A is here, A is also here, B is here as well as here, C and D both are in set A as well as in set B. Okay, so we can write set A is equals to set B. Now see the second one. In the second question, set A is 4, 8, 12, 16, and here 8, 4, 16, 18. So 4 is here as well as here, 8 is here as well as here, 12 is in set A but not in set B. So we can write this 12 this 12 belongs to set A, but 12 does not belong to set B. Okay, it means set A is not equals to B. All right, and also we have this 18. This 18 belongs to set B, but this 18 does not belong to set A. So this set A is not equals to set B. Now the third question is set A is given 2, 4, 6, 8, 10 and set B is the set of all x such that x is positive, even, integer and this x is less or equals to 10. So before you check whether they are equal or not, if you convert this set B in the roster form, then it will be more easy to find whether they are equal or not. So we'll write this set B in the roster form. So what is this x? X is a positive, even, integer. Positive integer and even integer. So positive integers means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But even positive integers means 2, 4, 6, 8, 9, 10, 12. But here it is given that this x is also less or equals to 10, means up to 10 only. So 2, 4, 6, 8, 10, we will not include 12 and other numbers because this x is less than or equal to 10. So this is set B. So here now see, both are equal. Okay, they have exactly the same elements. So we can write yes, set A is equals to set B. So if you convert the set in the roster form, then it will be more easy to identify whether they are equal or not. Now see the last part of this question. A is a set of all x such that x is a multiple of 10. X is a multiple of 10 means the elements 10, 20, 30, table of 10. Okay. And here set B is given 10, 15, 20, 25, 30, 35. But when you observe, you will find that this 15 belongs to set B, but 15 does not belong to set A. Okay. Similarly, this 25, but only if only one variable is in set B but not in set A, that's enough to say that the sets are not equal. Okay. So we can write that set A is not equals to set B. Okay. Now let's move to the next question, which is again based on the definition of equal set. Next to question number 5 and 6, both are in both the question we have to check whether the sets are equal or not. So again I am giving you these two questions for homework.